The another subject is so software developer, like that is developer associate. In developer associate, there are three topics we can do in 3 videos. The first topic is theoretical and conceptual foundation of Amazon SQS. Our faculty advisor is Victor Govindaswamy from Concordia University, Chicago. Introduction to Amazon SQS. A completely managed distributed messages queuing system is Amazon Simple Queue Services, created to separate serverless apps, event-driven systems, and microservices. Permits software components to communicate asynchronously. Guarantees dependable messages delivery even in the event of service interruption. Workload is automatically scaled. No manual infrastructure setup is required. Lessons tight connection to permits autonomous system evolution. Core purpose of SQS allows messages to be temporarily stored in a buffer before being processed. Facilities facilitative facilitative communication between parts that aren't physically coupled, allow backend services to process activities at their own pace by supporting load leveling, guarantees distributed applications fault tolerance, increase overall system reliability and resilience, effectively manages tasks increases. Key components of SQS queue service as a short-term messages storage space. Procedure provides the queue within information or request. The consumer takes messages out of the queue and process them. The main unit of data up to 256 KB is called a message. Avoiding repeated processing is possible with a visibility timeout. Dead letter queue or DLQ securely manages unsuccessful messages. Types of SQS queues. The standard queues provided at least once delivery, best effort ordering and unlimited throughput. FIFO queue guarantees exactly once delivery is maintains a strict messages order. Unprocessed or error prone communication are separated by DLQ. Dead letter queue. High throughput for FIFO. Benching allows for up to 3000 transactions per second. For performances, choose a standard for sequence integrity, use FIFO. Switching between application and application consistency and speed requirements is simple. Message lifecycle. Message sent by the processor, queued, obtained by the customer, processed and removed. During process, the visibility timeout hides the messages. If left unprocessed, the message is once again displayed. By default, messages are kept for up to 14 days. DLQ is where failed messages are automatically moved. Guarantees delivery even in the event of a large load. SQS architecture overuse. Based on the tolerant and distributed design, connected to AWS services such as step functions, EC2, SNS, and Lambda. Procedures use the API SDKs to push messages to SQS. Asynchronous messages processing and queue polling are done by the consumers. Allows several customers to read at once. Use multiple data replications to deliver high reliability. Security and access control. Permissions for procedures and consumers are defined by IAM policies. For data security, use AWS KMS within the server side encryption. Secure messages in transit are provided via HTTPS endpoints. Private networks access is restricted by VPC and endpoints. Allows access logging for adults using CloudTrail. Compliance with AWS compliance standards PCI, SOC, and HIPAA. Advantages of SQS. No servers need to be maintained. It is fully handled. Incredibly robust and accessible in several agents. Any messages volume is automatically handled via elastic scaling. Effectiveness is ensured by the pay as you go mechanism. Makes it easier to workflow is distributed system. Enhance microservices, fault isolation. Common use cases. Payment processing and order pipelines for online retailers. Microservices sharing of events in communication. Serverless programs that use asynchronous task queues. Prior to data analytics, IoT event buffering, workflow triggering and coordination for batch jobs. Lambda triggers are used in image and video processing. Comprehension with other AWS messaging services. You can see in these features model order retention delivery use case. SQS, SNS, Queue, PW, pub and sub stream. Thank you. The next topic in this video is practical use implementation or code explanation. Our faculty advisor is Victor Govindaswamy from Concordia University, Chicago. Creating a queue. Navigates to SQS, create a queue in the AWS console. Depending on your needs, select FIFO or standard. Set up encryption, retention, and visibility timeout. Give manufacturers and consumers access permissions. For API connectivity, take note of the queue URL. Use the AWS CLI or SDK to verify the configuration. Sending messages via AWS CLI transmits a single messages with a delay that can be set. Custom messages attribute can be added to metadata. Batching is supported with send message batch. Logs the MD5 hash and messages ID for validation. Effective or automation and scripting. Receiving messages. Retrieves several messages simultaneously. Long polling reduces the number of blank answers. Receipt handle is included for deleting messages. Avoid redundant delivery while it's visible. Perfect for application requiring bulk processing. You can see in this image how the receiving the messages. Deleting messages. After processing is successful, it must be completed. Prevent messages from being reprocessed. Performance is enhanced by deleting bench operation. Guarantees the correctness and dependability of the messages. Prevents the queue backlogs from growing. Example in Python, Boto3 SDK. Show how to send and receive messages. able to handle errors and do bench processes. Connects to Flask apps, step functions or Lambda. Ideal for Python setups with async workflows. You can see the code in the image. Import Boto3 SQS is equals to Boto3 dot client SQS. You can see in this video image. Integration with AWS Lambda. New SQS messages have the ability to automatically trigger Lambda and handles several messages at once. Lambda functions are scaled automatically. Removes the requirements for a specific customer code. Perfect for workflow without servers. Lowers overhead cost and infrastructure. Integrating SQS with SNS. Multiple SQS queues can receive messages published by SNS. Permits parallel consumers to use a fan-out design. Messages can be processed independently by each queue. Facilitate the system-wide distribution of notification. Ensures delivery assurance and message longevity. Handling failures in DLQ setups. When creating a queue, configuring the dead letter queue DLQ. Prior to transferring the messages, set the max receiving count for retrieves. Adds in the debugging of messages processing logic. Keeps the main queue free of inaccurate data. Keep an eye on DLQ metrics in CloudWatch. Strong systems that can withstand faults. Monitoring and metric. Import metrics through Amazon CloudWatch. Number of sent messages. The approximate number of visible messages. Estimated age of oldest messages. To identify strugglers, customers, set alarms. Dashboards can be used to see throughputs. Use the conjunction with AWS X-ray to trace messages. Cost optimization. Pricing is determining by the volume of request and data transferred. Optimize cost by employing length polling, sending and receiving tasks in the batches, deleting messages as soon as possible. Payloads are compressed whenever feasible. Utilize AWS Cost Explorer to track uses. One of the most affordable AWS services is still SQS. Thank you. The last topic in this video is applications, tools, and best practices of SQS. Our faculty advisor is Victor Govindaswamy from Concordia University, Chicago. Real world applications. Pipelines are processing e-commerce orders. Jobs involving pictures scaling or video encoding. Gathering and processing of IoT data. Analytics work scheduling in the backgrounds. Event communication across services. Message buffering for microservices and APIs. Design patterns. The procedure consumer pattern separates the sender and the recipient. SNS publishes to several SQS queues using the fan out pattern. The load leveling pattern events out nodes surges. Multiple FIFO queues or queues for job priority makes up the priority queues pattern. The dead letter pattern makes sure that unsuccessful messages are kept safe. Promotes fault tolerant and scalable architecture. Queue design best practices. When uniqueness and order are important, use FIFO. For application requiring a high throughputs, select standards. Set up a visibility timeout according to processing duration. Store use data in S3 and limit messages sizes to 256 KB. To save money, steer clear of lengthy retention periods. Turn on DLQs as soon as possible to improve debugging. Security best practices. Use IAM to enforce least privileges access. Use AWS KMS to encrypt messages. To prevent using the public internet, use VPC endpoints. Turn on alert logging for cloud trail. Regularly switch up your credentials. Keep an eye out for questionable uses of IAM. Performance optimization. Send and receive up to 10 messages at a time. Reduce API expensive by enabling lengthy polling 10 to 20 seconds. Use auto scaling customers according on the depth of weight. To increase throughputs, process messages concurrently. Reduce inactive users to save money. To cut down a request, each frequently used metadata. Developer tools. Python, Java, Node.js, Go and Net AWS SDKs. AWS SAM CDK for automatic infrastructure. AWS CloudWatch for tracking cores. To trace the flow of messages, use AWS X-Ray. For SQS local testing, use local stack. For testing at the API level, use Postman AWS CLI. Troubleshooting tools. DLQ examination for unsuccessful messages analysis. CloudWatch logs for problems made by Lambda consumers. Cloud Trail for tracking sent and deleted messages. Performance diagnostics with AWS X-Ray. To debug context, use messages attributes. Use scripts to reprocess DLQ messages in order to receive recovery. Integration examples. Serverless jobs processing with SQS and Lambda. Workflow authorization is a function of SQS plus step. Batch and containers processing using SQS plus EC2 and ECS. SQS plus S3 file processing based on events. Async database updates using SQS and DynamoDB. Extensively utilized in event-driven designs. Compliance and governance. SQS compliance with ISO, HIPAA, SOC, and PCI DSS regulations. Use Cloud Trail to log all API activity. Support retention guidelines and data encryption. Offers multi-agent durability for dependability in compliance. Perfect for regulated and enterprises grade settings. Use security event monitoring to increase visibility. Future of SQS. Keep developing for microservices and event-driven systems. Message filtering and increased FIFO throughputs are on the horizon. Improved compatibility with step function and event bridge. Expanding applications in IoT, machine learning, and artificial intelligence pipelines. AWS is AWS is concentrating on observability and latency reductions. Continues to be vital component of the AWS communication system. Thank you guys.